what is the vision of the fiber competition division at Cotton Incorporated. And our vision, our goal is to make cotton the most efficient and profitable fiber in the marketplace. And that's critical. This textile supply chain, you want them to be profitable by using cotton so that they continue to want to process and use cotton and create cotton goods. Fiber competition sits right here in the supply chain between cotton production and textile manufacturing. We like to say that we're responsible for everything that can happen to a bale of cotton from the time that it leaves a gin press until it is consumed in a textile spinning mill. And we do say that U.S. cotton is a fantastic supplier of premium fiber quality globally. And we want to talk to you about some of the challenges that we face with maintaining that reputation and what we're doing on our division to combat those challenges. We are, after all, called fiber competition. But I'm going to start by telling you about some of the challenges that cotton in general faces in terms of in the textile processing world. We're a natural material, and that is great for so many reasons, but it also creates some challenges in terms of the sourcing by textile industry folks for using this material. We're competing against synthetics and man-mades, and just for definition purposes, I'd like to explain that a synthetic is anything that is chemically synthesized. So that's going to be your polyester and your nylons, whereas a man-made fiber is going to be a regenerated material, such as rayon, where it starts out as a natural cellulosic product, but then it is regenerated chemically to create a man-made fiber. So what are some of the challenges that cotton faces? We are at the mercy of Mother Nature. We are at the mercy of hurricanes coming through South Texas, the Southeast, the Mid-South. We're at the mercy of extreme drought situations in West Texas. Even in a good year, we can face quality challenges depending on how we have chosen to manage our cotton. So there's going to be the potential of quality issues in our product. Even in a perfect year and in perfect management situations, we're always going to have variability in quality. And that's because how that cotton is grown, how those fibers initiate within the boll, how it grows along the plant from the bottom up and the inner out. You're going to have a range of properties such as length uniformity and micronear all across that plant. So there's going to be variability in our material. And we are also genetically limited in what we can do in terms of properties such as length and strength. We can make advances, but it's not as easy as doing an engineering step in a chemistry lab to create a super long or super thin fiber. So those are some of our challenges as a natural product. It gets even more interesting when you're a textile mill trying to buy cotton. If I'm going to be processing polyester or rayon, I'm going to pull up a catalog website. I'm going to punch in the quantity and the properties that I need. I'm going to swipe my credit card and I'm going to be done. It's going to be en route to me. Whereas the cotton, I'm dealing with what's the variability in pricing, what's taking place with the futures market. On our side, we have the challenges with the discounts and the premiums and what the market demand is going to be. As a textile mill, I have to apply for a letter of credit. I have to clearly understand contract terms. The change of one word with regards to micronear can radically influence what a merchant is allowed to ship me. It can greatly impact my business. And then, of course, availability, not only the availability of U.S. cotton, but I'm processing all year round. What's taking place in other parts of the world? What's the availability of those cottons? Can I find the qualities that I need for the products that I'm wanting to make? And then beyond that, it's getting the cotton. What happens to a bale once it leaves a gin is just incredible in terms of the amount of times that it is moved and it transitions. We do face challenges that it's going to take us close to 2 months to get that cotton to parts of Asia. And as a result of that, textile mills that are processing cotton have warehouses and they stockpile that cotton. And so have they bought the right qualities at the right times? Can they afford that inventory? And then how are they going to best use that inventory versus maybe just quick shipments of synthetics that they can basically get on demand as they need it? We also have the challenges of what happens to our cotton during transport, what happens to that bale packaging, what happens that can lead to contamination issues or other problems with that cotton. And then as a textile mill that is storing cotton for a period of time for my inventory, In parts of the world, I only have outside storage. What's happening to the condition of that cotton during that storage period, and what impact does that have on my processing? So those are some of the challenges of cotton versus an easy to use polyester or rayon. But the advantages of cotton and the market potentials of that drives the demand for and the use of cotton by these textile industries. And so it's our job within fiber competition to protect the reputation and the marketability specifically of U.S. cotton. And we have activities that are also meant to support farm profitability for U.S. cotton growers. So today you'll hear me talk about activities such as Fiber of the Future. I'll tell you what we are doing about our contamination challenges. And then I'll also explain to you our software system, the Engineered Fiber Selection EFS system, and how that can help drive and support the demand for U.S. cotton in the marketplace. So within our division, we consist of two different departments. Our fiber quality research area is the measurement side of the division. This is our testing lab based in Cary, North Carolina. It's also all of our outside research. It's where we're focused on understanding current test systems, looking at new fiber testing systems, understanding the use of the data, and even presenting that data information. We collect all the data from the USDA on fiber quality, and we promote and talk about that fiber quality globally. On the cotton management system side, this is our engineered fiber selection, EFS side of the program. That's the logistics portion. That's the software suite that's used to capture all that data and help a textile mill effectively use it in their processing. So we are that bridge between ginning and the textile spinning industry. We're making use of all that data that is provided on every single bale of U.S. cotton and providing software tools to the textile industry to help them maximize the use of that data to process efficiently. And that's the goal. You have to be efficient in your processing if you're going to have any potential of being productive, and without productivity, there's no way that you can achieve profitability. So within our research area, we fund anywhere between 10 and 15 research projects each year. This is the current package of projects that we're working on this year. I don't expect you to read all the titles of this. If I were to summarize this into common themes, the keywords that would stand out are going to include length uniformity and contamination. Those are our top priorities within our research area, and I'd like to cover each of those priorities as part of my presentation today. Who does the work? Well, this is Cotton Incorporated funding through contracted research. It's managed by an individual on my staff, Dr. Neha Kathari, and she has projects that are located in a variety of groups around the U.S. and around the world. So we work with all three USDA GIN research laboratories, as well as the USDA Textile Center in New Orleans. We work with public universities anywhere where we have a cooperator that has the capability of working on a priority of which we are focusing. We have strong collaborations with the Biopolymer Research Institute at Texas Tech, and we even work with the Australians. There's some common challenges for both U.S. and Australian cotton, where it does make sense periodically to do research work in this area. So, the U.S. is the world's most reliable producer of high quality cotton, and I would agree with that. If we look at our long-term trends for length and for strength, we've continued to see improvements over time. We, of course, have those dips that occurred in the years in which we were transitioning to genetically modifications. The first fold guards that were released were due to back crosses, and so we did take a step back in quality at that time. But the improvements that have been made in the last 15 years have been significant for both fiber length and fiber strength. And I would say even in more recent years, what we're seeing with fiber length is just incredible. I mean, we pushed the breeders going back, I think in 2005, I started in fiber quality research, and the number one thing we were hounding on breeders at that point is fiber length, fiber length, fiber length. And I think they accepted and pushed forward that challenge. We will continue to see improvements in both fiber length and fiber strength, which does set us up as a reliable supplier of high quality cottons, but we're not perfect. One of my jobs is to take a look at, well, where aren't we seeing improvements? Where should we be putting our research focuses going forward? And when I look at length uniformity, that's a fiber property that long-term we are seeing a decline. And that's a concern. As we continue to push forward fiber length, if we don't also support a minimum level of length uniformity, it doesn't matter how long we make that cotton. If I don't have a length uniformity that's good enough to allow me to use that longer length fiber, then it didn't really matter at the end of the day what that fiber length average was. So this area of length uniformity improvement fits under a program that we call Fiber of the Future. And the concept of fiber of the future is to push the breeders, to push them outside their comfort zone, to have them focus on improvements for properties that they might not normally think about. They're always going to focus on yield, which is important and critical for our programs. They're going to keep length and strength in mind. But things like length uniformity, we have to evaluate if they're not focusing on this. Is there a reason that they're not? Is there a lack of a measurement need? What can we do to help them in this area? And the reason that length uniformity is important is that cotton is competing against the synthetics and athleisure wear, the rayons in women's tops and dresses. Those are predominantly thinner, lightweight fabrics. In order to make a thinner, lightweight fabric, you have to be able to make a thinner yarn. And what you're seeing on the screen here is the structure of a ring spun yarn. Ring spinning is the predominant spinning system that is used globally, and it is formed by aligning those fibers together and twisting them. So the properties of length and a consistency in that length is very critical to the mechanics of how this yarn is formed. And if I want to make a thinner yarn, the longer my fibers are and the more uniform those fibers are, the easier it is for me to make a thinner yarn. If I have a poor length uniformity, I'm going to have to put more fibers across that yarn structure just to get the integrity, and it's not going to be the thin yarn that I want for competition. And this is who we're competing against. We have our filament polyester on the right screen. Can be as long as it wants to be, can be finer than a human hair. Cotton is really competing in this area on the photo on the left side. That's cut staple polyester, cut to any length that it wants to be. And all those fibers in the bale are essentially the same length. It's like having a length uniformity of 100. This is cotton. We're a natural product. We're always going to have variability. We're always going to have a length distribution. But if we could focus on producing cottons in which that length distribution was stronger in this area and we had less of the shorter material, that's going to be an easier fiber for a textile mill to process and can open up market opportunities for different products for cotton in the future. And textile mills have been asking for this. A survey that was done by the Bremen Institute in 2016 and 2017 asked 2,000 spinning mills in 28 countries if you could drastically improve one single fiber characteristic about cotton, what would it be? And overwhelmingly, it was the length-related properties, and that's both length and length uniformity. If you look down the line, you see strength is second and fineness is third. We're transitioning some of our research efforts in Fiber of the Future to see what we can do in the area of fineness, because again, if we could tap into genetically driving the fineness, the thinness of upland cotton to thinner fibers, that widens the door for the type of yarns that can be made and the type of product categories we can compete in going forward. Regardless of how good our fiber quality may be, unfortunately, for the last 5 years, when I visited textile mills and I'm there to talk to them about our superior fiber quality, I barely get a chance to talk about it because they're too busy handing me bags of contamination. And it's not very comfortable to be sitting across the table from a gentleman such as you see in this photo, who has just told me that if he wanted plastic in his bales, he would be buying bales of polyester. This is a challenge that we have to overcome. We can do whatever we can to improve our qualities, to improve our logistics and the use of our cotton, but so long as we have a contamination problem, it is hurting our reputation and it's impacting the premium that we're getting for U.S. cotton. There's a lot of information on this screen. We're going to start in the top left. What you see here are the plastic calls and the last 3 crop years from the U.S. classing offices. The blue line is the size of our crop, and the green bars are the number of calls for plastic. And so unfortunately, regardless of this crop size, for the last 3 years, the number of calls for plastic contamination has been increasing. When we look at the bottom left of the screen and the colors that are being found in those classing calls, I'll point out that the blue is the new Econo Wrap available from Tama this season in limited supply. And if we account for all colors of round module wrap, the blue, the pink, and the yellow, that's 85% of what's being found in classing calls with plastic present. We can't overlook the black at almost 10%. That's our black agricultural mulch. That's been in our cotton much longer than the round module wrap issue, and it's something that we still need to take seriously as a problem as well. The graphic on the right, we are showing you the difference in cents per pound for medium and high grades cottons compared to the same grades, the average of other exporters globally. And so what this graph represents is about a 5 cent per pound premium loss over the last 4 to 5 years for U.S. cotton. Now, there are many things that have occurred in this time period. We've had the trade issues. We've had increases in U.S. stocks. The export market has changed. We're not competing against Uzbekistan and India. We're competing against Brazil. But also we've had the challenges with contamination increasing over the last several years. I can't tell you how many cents per pound we have lost just due to contamination, but keep in mind when we're producing a 20 million bale crop, every cent per pound that we're not getting as a premium is $100 million lost to the U.S. cotton producers in the industry. What are we doing about it? You have all 3 research divisions at Cotton Incorporated focused on contamination. We have grouped this into the fast fix Band-Aids, things that we think we can get to the market quickly. They may not be perfect, but they'll start to help with the problem. Then we have our intermediate source solutions. These are concepts that we think will be more robust, have a greater potential of having an impact, likely occur in the field or in the early part of ginning at the module feeder, but they'll take longer for us to get those technologies out there. Longer term, we do have to face the fact that we're wrapping a natural material in plastic. How could we potentially completely eliminate plastic from our system, both in terms of module wraps and bale packaging? That's going to be a significant hurdle for the industry to work towards in the future. The activities that you see highlighted in yellow are the activities for which Fiber Competition is responsible for. The first one is the Viper. This is the visual imaging plastic removal system. It is a series of color cameras and air ejection that are housed right above the gin apron feeder. This technology is currently available from Loomis this season. It had a very successful beta test this past season. We were seeing about a 90% ejection rate of spike samples for a variety of different colors of module wraps in different sizes. So we think this technology has potential. We're still researching on how to make it better. So first generation's out there, but the improvements to make this an even better system is going to continue in the future. The Golden Line is a system that we got from the Chinese. We heard a lot of good things from the Chinese textile industry, where they have a problem with clear agricultural mulch, and the Chinese produce cottons. This system consists of a series of stick cleaners and then a large air chamber. This is the part of the system that we're interested in from a research perspective. See, cotton is blown up with an air fountain to the top. It's heavier, it falls down. Plastic should float to the top and be caught on this condenser and concentrator and be removed from the system. Unfortunately, this is a research effort that has been impacted by stay at home. We're not as far as long in the evaluations as we'd like to be for this technology, but we're hoping that there's something that we can learn for this that might be added to other technologies that we're pushing forward in the future. The last thing for contamination that I wanted to share with you today is that there's a lot of effort been done by a lot of folks, the council, variety of universities, USDA groups, Cotton Incorporated funding, on module camera systems. And the folks at the Lubbock USDA Gen Lab put together a wonderful paper. The link for it is at the bottom of your screen here. This tells you how to go out today, get cameras and install them at your module feeder, and the availability of open source software to allow you to do monitoring. From a research perspective, we'd like to move these kind of technologies from the passive, where you have to stop the module feeder and physically look at the camera to see if there's an issue, to the future, where we make use of some of the technology that's in the Viper system, and it automatically detects and alerts that you have a problem in the module feeder. So stay tuned for what may come in this area. If you were here in Cary, North Carolina, attending a producer tour, you would be told that this afternoon you're going through our testing laboratories. And of course, you don't get to do that today. I can tell you that the labs at Cotton Incorporated are in operation. We're staffing at about 50%. We're following all the protocols in terms of safety. The staff are comfortable. They're happy. They're so happy to be back in the labs doing what lab staff do. And so our lab provides all the fiber, yarn, and fabric testing in support of all research activities and marketing opportunities for Cotton Incorporated. We have a conditioned space. They do a wide range of testing. Maybe at some point in time, we'll take a video tour through the labs and share that with you all to see in the future. And please, when things return to normal, you're always invited to come to Cotton Incorporated and visit the labs. Finally, I'm going to cover the activities within the EFS portion of our division. This is where we are providing a suite of software tools that allows the textile industry to make use of all that wonderful data. And that's the challenge. HVI data on every single bale of U.S. cotton is a lot of data. When I'm a cotton buyer and I'm a textile spinning mill manufacturer, and I go out in that warehouse and I'm going to pick and choose which of these bales I'm going to put together in a laydown. And a laydown can be a group of anywhere from 20 to 120 bales that hopefully I've correctly mixed together, similar qualities, so that I'm going to get a good product when that goes through the spinning system. We offer software tools to allow with that to take place effectively. MillNet is the actual EFS software workhorse tool. It's used by both merchants and textile mills to look at their inventories. For a textile mill, it's how they're going to create laydowns. It's how they're going to decide within the inventory of cottons that I have, what can I pick and choose to put together? What am I lacking in terms of quality that I need to be sourcing? How do I mix those bales together effectively and efficiently? We also have the U.S. crop software, which tracks and keeps up with all the classing data from the USDA so that you can look at what's taking place by both state and classing offices. Researchers use this tool extensively to map the trends in U.S. fiber quality. Textile mills use it by saying, I'm seeking certain fiber qualities. Are they even available at this point in time? And then, of course, Cotton Communicator is just essentially our electronic data exchange. It's that communication between the merchants and the mills. Regardless of what yarn I'm making, polyester, nylon, rayon, cotton, 60% of the cost of making that yarn is that raw material. And that's why it's extremely critical that that raw material meet my needs, that it is that premium fiber quality that I'm seeking, and that I use it effectively and efficiently. And that's why we have EFS. We can help the textile industry control their inventory costs because they are only attaining the qualities that they need. They don't have to overbuy. If you don't have a simple control system, if you're relying on spreadsheets and spending weeks to do regressions, the safest bet is you're going to buy the top of the line premium qualities on the market when you don't really need it, just as an insurance. With EFS, you have the ability to get the qualities that you need, so you're not spending too much money on what's costing you 60% to make that yarn. EFS does rely on HVI data, so it's traditionally been a handcuff to U.S. cotton. I would say that today it's a handcuff to U.S. cotton because it's a licensed product connected with Cotton Incorporated and all the technical support, not only from fiber competition, but our fiber processing, all the marketing information, economics, everything that we offer from a company helps to keep these individuals linked to U.S. cotton. And we rely heavily on our communications with these groups. The way that it works, this is a photo of what we call the mothership. This is the database in Memphis, Tennessee that houses all the data for every bale of cotton produced in the U.S. Before it's even arrived at a textile mill, the software has allowed them to map what's coming in for them in terms of quality and how they're going to start to manage those cottons. Textile mills create what are known as groups and categories based on the fiber qualities that they are going to control, usually micronair and plus B. They create breakpoints so that they can tag those bales and create quality designated piles in the warehouse, so that when it comes time to create a laydown, I don't have to hunt and choose for one PBI. I can pull any bale within that stack because it fits the quality parameters that I'm looking for that portion of my laydown. We control not only the averages, but the deviation, and that's done for every single laydown today, tomorrow, next week, next year, to provide that consistency. It's the consistency in your quality that keeps your customers happy. And if you don't control properties such as micronair and plus B consistently, you can get a defect known as bar A, where you get unintentional banding within the fabric. Now, we engineered this. It doesn't look this consistent if it happens naturally, but this is from combining different micronairs. It should not have been combined together. And systems like EFS can help minimize the potential of these defects. We have 57 textile mill groups globally that are using this system. Our biggest customer outside of the US is Vietnam, and this changes. China was our biggest customer probably 5 to 10 years ago. We follow where US cotton goes, so long as it's going to a place that we're allowed to travel to and to provide the software services that we can provide. So there's a lot of customer service associated. We work very closely with the textile industry. This is what it used to look like. Last year we did 100 trips, my division, and that included EFS as well as research and the work that the lab staff do, but 100 trips to visit our customers. This is what customer service looks like right now. As soon as the stay-at-home orders went into place, immediately we were in contact with our EFS licensees. We did a lot of work to help a lot of textile mills be able to operate remotely. We installed software on laptops for workers at home. We retrained individuals. Typically, EFS has more than one operator depending on what role you play. And if the textile mill was choosing to keep just one person at the textile facility, they got very thorough retraining remotely from our team so that they could fully operate the software system and keep those textile mills processing. There's a lot that we've been doing. We have had the opportunity to visit one of our US clients to provide some services to them. It gave us an opportunity to also test out some research work that we're doing about remeasuring color on bales in the warehouse. Here we have a handheld barcode reader and how we can read a PBI tag and update information. Research side, we've also been in contact with all of our research cooperators. We didn't get to plant everything that we wanted to plant this year, but for textile labs such as the FBRI at Texas Tech that are now reopened, that staff is working overtime and we're rapidly catching up on some of our research efforts. We can't visit our clients. We've sent care packages. They've received hand sanitizer and cotton stocks. Stay safe, stay comfortable with cotton. And then a couple accolades for our division at the bottom. Customer services are highly important right now. And it's very important that we continue to engage and stay with the industry during this time. And that's what our role is. Our role is to interact with the industry, to educate them, to promote U.S. cotton to them. Whether we do that remotely today and hopefully before too long hit the road again and go visit them in person, that's our goal. So I've talked a lot about U.S. cotton, the promotion of U.S. cotton, but I always have to remind you, fiber competition, it's not Australian and Brazilian cotton we're competing against. This is my catalog. I've just picked what diameter and length that I want. I'm swiping my credit card and I've just bought what I've needed for the next week in my textile mill. There's a lot that we're doing to fight this kind of competition. We're very excited about our research and our programs, and I thank you for your attention this morning.